Hey there, I'm Nix, and the video for today is going over the reverse words in a string problem on the LeetCode website. As always, we're doing this in C++, and I'm going to give you a detailed explanation of the entire process, through the planning of the algorithm, to the coding of it, to the analysis of time and space complexities, as well as looking at LeetCode rankings. If that sounds good to you, then stay tuned. Welcome back to the last problem to solve in this Explore card. As the last video I did, I went ahead and solved the reverse words in a string 3 problem and kind of leapfrogged over this current problem here. And now you get to see the details of why exactly I did that. So let's get straight into it. We are given an input string, s, and we want to reverse the order of the words. We are given a definition of what a word is as a sequence of non-space characters, and that the words in s will be separated by at least one space. We want to return a string of the words in the reverse order concatenated by a single space. And the note makes what is being implied in these statements crystal clear, is that S may contain leading or trailing spaces, or it can even contain multiple spaces between the two words. But we want our return string to only have a single space separating the words, and we don't want any of the other extra spaces. And then we're given a bunch of examples to drive home the points. In the first one, a very basic example, we're given the sky is blue, each word separated by a space, and we want to return the reverse of that string, so blue is sky the is the output. Next up we have hello world with leading and trailing spaces here, and we just want to get rid of those extra spaces and then reverse those two words. Example 3 has multiple spaces between the words, we also don't like that. And then 4 has all of those things together, so leading spaces, trailing spaces, multiple spaces in between, and so many spaces. And then finally in example 5 we just get another typical sentence that makes us feel bad for Bob's unrequited love. Looking at constraints here, the string can be very short or not so short. We know that the string can contain upper and lowercase letters, digits, and of course spaces. And we're guaranteed that we have at least one word in the string. Finally, a follow-up is at the end and asks us to solve it in place with big O of one extra space. Now that we have all of that information, how are we going to actually solve this problem? Well, one way you can do it is by essentially ignoring the follow-up question and using extra memory, creating extra string variables as a part of your algorithm. For example, you can have a string that will house your final result, and you can have a string variable that will house each word that can be added to that final result. The way to get a word is, since we want to add these words in reverse, let's reverse through the initial string via a loop, and you can add each character that you see to this word as long as it's not a space. Once you have a word, then you can add that word to your result string by concatenation. Now with this brief outline, we have a few things to consider. We're going to need to think of a way to deal with multiple spaces between words here. Because if we're using the space as a delimiter and a signal to add the word to our result string, then if we have multiple spaces, we want to make sure to add that word we have only once. So we don't get into a situation where, hey, I see a space. I should add the word example to this string. Hey, I see another space. I need to add the word example to this string. Hey, I see another space. You get the idea. So we need to figure out how to ensure that doesn't happen. Another thing we have to make sure we deal with is that although some strings can have leading zeros here, and that if we see a leading zero, we'll be able to add that first word that's in the string, that may not be the case for all strings that we're given. So once we've reversed all the way to the end here, and we add the word the to our string variable, then we get to the end of the string, and we never see a space that we're using as a signal to add it to our result. So we need to figure out how to deal with that as well. Finally, we need to make sure we add only one single space between the words. No more and no less. So going over all of that, let's go down here and start the coding process. Here are the variables that we're going to use. As I talked about earlier, we're going to have a string we call word. And we initially set it to be empty. We're also going to have a string that houses our final result, termed result. That's also initially empty. And finally, I have an integer variable that I'm going to use to deal with those multiple spaces. This is going to be my space counter, and I'm going to set it initially to 0. Next up is the reverse for loop. And this for loop, as the comment here says, is going to function to add each character that we see to build up our word string, and then add that word string to our result string. Since it's a reverse for loop, I is going to start at s.size minus 1. It's going to go as long as the index is greater than or equal to 0, and it's going to decrement every time. The first thing that we want to do in the for loop is check to see if the character that we're currently looking at is a space or not. If it is not a space, and thus is a letter, a number, something that we want to add to the word, then we want to make sure our space counter is still 0 and that our word is now equal to that letter plus the word. Since we're moving across the string in reverse, we want to make sure that the letter that we see always goes in front of our currently building up word. Next up is flushing out this else statement. So if we're in this else branch, then the if condition here is not true. In other words, we've run into a space. The first thing we want to do is count that space. So our space counter variable increments up by 1. Now, if that space counter is equal to 1, we can go ahead and add that word to our result string. But the specific way we do that is going to depend on whether or not that's the first word that we're adding to the string or not. Because if it is, we can just add that word. But if it isn't, we're going to have to add a space to separate this new word from all the other words present. And the way we do that is a check of two separate conditions. We want to ensure the space counter is equal to 1, and this is going to help us guard against adding the same word multiple times, even if we see multiple spaces. The second thing that we want to check is the current size of the result string. If that result string doesn't currently have anything in it and its size is equal to 0, well then we're adding the very first word that's going to go into it. So we could just directly add that word by string concatenation. And we want to reset the word back to 0 so that this if branch, once it finds another thing, can build up a new word. Now, if the space counter has reached 1 and our result string is not empty, so its size is something greater than 0, then what we want to do is add that word by setting the result string equal to itself plus a space, then the word, and then of course reset the word again. Now this for loop is going to be able to handle seeing multiple spaces between words. It's going to be able to handle when to add a space and when not to. It's going to be able to handle only adding a word once to the result string. But it can't handle the situation where there are no leading spaces before the first word in the string. In other words, it can't handle this situation, it can't handle, say, this situation, where it builds up the word Alice, sees no space, and thus this else branch, which triggers only when we've seen a space, won't add the word to the result. Now we can fix that by simply changing this else branch into an if statement instead. With this change, once this if statement does its thing, then this if branch will evaluate. Now the first condition here functions exactly like the else branch used to. So if the value that we're looking at is not equal to a space, Well, if that's false, then the value that we're looking at is equal to a space. And if that's true, then stuff is going to happen. The additional condition we want to check for is if the index that we're at is equal to 0 and the value at that index is not equal to a space. This is the condition that's going to include the scenario that wasn't being handled beforehand. Then the code is going to execute in here, and the first word in that string that doesn't have any leading space to it is still going to be added to result. The final step is to simply, outside of the for loop, we want to return our result string. And with that, the code is complete, so it's time to start clicking buttons and be judged. Okay, we have the string exactly as what we expect, so let's go for the full shebang, wait a bit, and get green text. Excellent. Now before we go and see our rankings here, let's do a bit of complexity analysis for this code. Time complexity is going to be dictated by this for loop and by string concatenation. String concatenation takes a bit of time to carve out the memory and copy everything over. So with that being nested within a for loop that is itself being dictated by the size of the entire string, this is going to have something akin to a big O of n squared time, which isn't the best. Its memory usage is also not going to be good. We have the memory usage for every single time we're concatenating a string, which is happening constantly, and we're also having the memory usage of simply needing the space for allocating the string variables itself. So this is going to take a lot of space, and we can see that in the rankings itself. So we appear here in terms of runtime. I've seen this type of algorithm ping pong all over the place in terms of a distribution. So keep that in mind and take it with a very large grain of salt. In terms of memory, yeah, it's not good. It takes a lot of space. So in order to avoid this horrible ranking, let's try to solve this problem and get somewhere into this zone. And to do that, we're going to need to create an in-place solution. So let's see what that's going to look like and how we do that. Since we have to make all alterations of the string in the string itself, what complicates our efforts are all of these potential extra spaces. The possibility of leading spaces, trailing spaces, having multiple spaces in between, all of those are eventually in the final string going to be eliminated. So why don't we take care of those extra places first? In other words, the first part of our algorithm is going to be shifting all of the words up to the front of the string and make sure that they are separated by only one space. Everything else, all of the extra places, the duplicate characters left over, is at the end of the string. Then we can loop through that portion of the string in reverse and eliminate all of that junk. That means that no matter what type of string we're given, like this one for example, this is the kind of string we're always going to have afterwards. The next section would be focused on reversing the words in the string. Now, a quick and dirty way to get all of the words in their correct relative order is to simply reverse the entire string, like this shows. Unfortunately, that has a side effect of reversing all of the characters within all of the words as well. But we do have Bob in the correct place, we do have Alice in the correct place, so on and so forth. But now you probably see why I did this problem first before I did this one. Now that the string looks like this, it essentially whittles down to exactly this problem, where in order to get what we want, we just have to reverse all of the characters within each word while maintaining their relative order. But we've already gotten code for that. We've already talked about this in the video that I did last time, which I'll leave a link up in the corner here. So we already know how to deal with that. And as a result, this algorithm is little more than making sure we get rid of all of the extra junk out. Get rid of all of those extra spaces, get rid of all of those duplicate characters. So with that plan, let's get to working. Let's reset here and start looking at the code. First up, as always, are the variables. I'll need 2 integer variables to accomplish this. An integer called position, which I set initially to 0, and another integer that I call char to delete, or character to delete, which I initially set to the last index in the string, s.size minus 1. Next up is the loop that functions to shift all of the words and everything that we care about up to the front of the string. Typical for loop, as you see here. And inside we have an if statement that checks a couple of things. We want to see if one condition or a combination of a few others is true or not with this OR operator. The first thing that we're looking for is if the value at the index we're on is not equal to a space. If that's true, then we're gonna do some stuff. The other condition is a combination of 3 other things that all need to be true. The first is that the index can't be equal to 0. We also have to be seeing a value at that index that's equal to a space. And finally, the character that's at the index right before it has to not be a space. If all of those are true, then again, stuff happens. The stuff in question, as you can see, is it sets the string character at the position index equal to whatever the value that we're looking at is, and then increments the position. So this is going to be what shifts things up to the front. And as you can see, it's going to do that every time it sees something that isn't a space. But we also have to be able to find a way to shift and guarantee that there is a space between words. And this is what the second condition does for us. So as long as we're not at the beginning, index is not equal to 0. We have to also see a space, but that space has to not be a multiple. The way we guarantee that is we look at the space right before that and see if there was something that wasn't a space that came right before it. So if all of those are true, then that is a space that we actually care about and want to maintain between our words, so we'll move it over to the correct position. Looking at the example here, if we're initially given this string, when this for loop starts to work, look what happens. We start at the beginning and we check our conditions here. Well, this part isn't true because we're looking at a space. And of course this part isn't true because our index is initially 0. So we move on to the second space here. This first part still isn't true. The index now is no longer equal to 0, so that part checks out. Our character that we're looking at is indeed a space, but this final check turns out to be false, because the previous character that we saw was still a space, which means these lines don't execute, which means our position is still staying right where it is initially at, 0. Finally, however, we get to the M. And the M fulfills this condition here, so our S at position 0 is going to be set equal to the character that we see. So this now becomes M, and the position then increments up by 1. And as this for loop continues to execute, it's going to change this string into this string here, where all of the words are shifted up. There's only one space in between them, and then we have some extra junk at the end that we need to get rid of. Now note at the end of the for loop where our position is in this string. Let's imagine that we've just shifted over the E, so our position is going to increment via this line. So we're going to be at the space here. Then we're going to be looking at, well, the space that comes right after this E. which is going to fulfill these conditions, and it's going to, well, substitute a space with a space in this situation. But now our position is essentially going to be right here at this duplicate C character. So keep that in mind, that that is where our position is. Next up is another loop that is going to erase all of this junk that we don't care about. Now, because I don't exactly know how many things are going to be present at the end to erase, this is a good place to use a while loop instead. And the condition I'm using is that as long as our position integer is less than or equal to the character to delete, then we continue on our merry way. And what I'm doing is essentially just calling the popback function, which deletes the character at the end of the string. Then I decrement character to delete, and then as long as our position is not equal to character to delete, it's just going to do that over and over and over, deleting off the extra junk one at a time off of the end. Then once it hits the position, remember in this example our position is here, so this while loop is going to eliminate everything all the way up to here if it was just these two lines of code present. However, because we had trailing spaces at the end of this string, one of them wound up being put after the word cute and our position incremented. So if we just stop at our position, we're going to have a trailing space at the end, which we don't want. To deal with that, this if statement is present. This if statement looks to see if position is equal to char to delete, and then it also looks at what character is at s position minus 1. So what's right before our position integer. And if that's equal to a space, we know we want to call pop back just one more time. And that will get rid of that space. So this string, now after this while loop is complete, becomes this string. Next up, we call reverse through the beginning all the way to the end of the entire string. And this, as its name suggests, completely reverses the string. So we do have the word cute at the beginning of the string. Is next, cat follows, and my is at the end. The only issue is that the individual characters are all reversed as well. But the order of the words is correct. Now we just have to fix all of the characters, and then we're all set. To do that, I want to reset my position integer for the upcoming loop. And now I can just finish off the algorithm by reusing the code that I used for this problem here, which is right here. And because I've already gone over this in detail in a previous video, I'm not going to artificially inflate the length of this already long video anymore by rehashing what I've already talked about. But this is exactly the same as the code in this problem here. So with that, this entire code should be complete. Just get rid of these. And now we can run code, see if it works. Okay, good. We get what we want. Let's go the full shebang. Wait a bit, as I am judged, and we get green text. Excellent. Little bit of complexity analysis before we look at the rankings. And this one, because it is an in-place algorithm, I don't have any strings, and I don't have any string concatenations to do. This is truly a big O of 1 space complexity. For time complexity, this is also quite good as well. Although I have several loops present, because again I don't have those string concatenations, I have a better time complexity. So let's see what it is. This for loop is dependent on the size of the string, so let's call that n. This while loop is going to run only as many times as there are extra places in the string that don't need to be in its updated version. And that's always going to be some fraction of the size of the string. But since we don't care about constants, and thus we don't care about what that fraction is, we can just say it has also dependent on something akin to n. Reverse is also going to depend on the size of the string. And of course this for loop and this reverse depend on portions or the entirety of the string size. And because they are not nested within each other, this entire algorithm essentially evaluates to something along the order of big O of n time complexity. So, pretty big improvement relative to the previous solution. So let's take a look at our rankings here. We pop up in this area, so that's interesting. And we have achieved what we wanted to do. We appear in this distribution. Much better than appearing way out in this range here, huh? Anyway, that was how to solve the reverse words in a string problem. I hope this video helped you out in some way. If it did, consider subscribing. And as always, I will wish you happy coding and to have a nice day.